So you guys were saying that you want me to get on your website, huh? Get on your blog and you could videotape me teaching math?
Yeah.
And then, so Math Genius Making can teach math to some friends?
Yeah.
Alright, that could happen. Alright, meantime, it's Crewton Ramone's houseofmath.com, and my little boys right here are going to do some square numbers. So show me some square numbers. Just build some square numbers.
I didn't want square numbers.
I didn't ask you what you wanted. I asked you to build some square numbers. In the beginning, when I asked you, what do you want to do today for math, because we could be doing all kinds of stuff, you're like, I don't know. So we will do, you said you wanted to factor some polynomials.
No, I didn't build the...
Factor polynomials.
No, I didn't put the x's in all the stuff.
Yeah, factoring polynomials. That's what it is. That's what it's called. Right?
I want to put...
Little kid talk is making rectangles, right?
I want to.
But what it's called is factoring.
Like this.
Yes, I understand. First, build me some
Square numbers?
Square numbers. You too. Here, get your own tray of stuff.
9
So, there, 9 is a square number. Build me another square number.
4 is a square number.
Oh, build it. Go ahead. You can build. It doesn't matter what he does. You can build your own. You can both build the same. So he understands that 4 is a square number. 1 is a square number. Very good. Oh, 100 is a square number. Look, I built that one. Cheated. All right. So build me square. So you got 2 4s. Build me something else besides 4s. Anything?
That's all I could think of.
Well, build something else. Your brother's trying to build a 5 square number. How about you build a 4 square number with 4s?
Is also a square number.
That's good. That's good. So you know what square numbers are. Let's see. He's building a square number. He's using 4s. How many 4s do you need to make a square with?
24.
Very good. Oh, have you got a square number, or did we get too big there? Not square yet. Very good. What do you think? Is that square?
12, 18, 24,
Like it?
30. 30 is a square number.
Alright. Is that a square number? That's 30, but is it square?
No.
Look at that one. What do you think?
36 is a square number, I meant.
Okay. Do you think this one's square?
Yeah.
Take a look at it. What do you think?
Yeah. No.
Or some examining. Alright, you don't think it's square?
Yes, we do.
Alright, let's see. With my camera and on, okay, I can see that 36 looks pretty square to me, although on my viewfinder here it looks a little rectangular, but actually it's square because it's 6 by 6. Let's look at that. Okay, now if we made it like that, that's definitely not square. So here's square. It's square this way, and it's square that way, right? And it's 36. Okay, so we can fool around with square numbers. Now let's just play around a little bit and use our imagination. Okay, and that's the most fun part. If this is a square, and it is, and I say it's 1, then that's a 1 square, right? But what if I use my imagination and each one of these was 2? Then this would be a 2 square. How much would this be right here?
A 3.
How many would it be? This would be 2, this would be 2, this would be 2, this would be 2. So how much would that actually be? Think about it.
This will be 2, this will be 2, this will be 2, and that will be 2.
Yes. How much would that be? I'm doing calculations.
That.
How much would it be? Very good.
It'll be 8.
Yes.
2, 4, 6,
2, 4,
10,
6, 8. Right? Alright. So great. How much would that be then?
Ooh. If that was all 2s?
Yeah.
18.
18. 2 times
2,
9.
4, 6,
Right?
8, 10, 12,
Okay,
14,
now,
16.
let's see here. So now, and I'm just going to talk about it and put the concept in there. This right here, if this was 2, then the side of it, we have to figure out what the side of it is. Like on the side of this one, this is a 3 square. It's 9. That side is how much? Right there.
3.
3. So 3 times 3 is 9, right?
Daddy, and this side is 2.
Right.
2 on this side, 2 on this side.
And the whole thing is what?
4.
Okay. Now, if this whole thing was 8, like when we were using our imagination, we'd have to figure out what the side is. Now, I have to look at this and figure that out, and it's going to take a minute to explain it. Hold on a second here. Okay, so we're having a little lesson on square roots now, just for fun. So I look at this, and we're trying to figure out what one side would be if the whole thing was 2. Uh-oh, you know what I need is a new battery. Fortunately, I have one right here. Look at that, brand new, fully charged. Alright, but let's run this down a little bit more. So this is square root of 4 times square root of 4, and square root of 4 times square root of 4 is how much?
Square root of...
4 times square root of 4 is how much?
2. I mean 4.
Good. Square root of 4, good. Self-corrected. Looked at me and got no positive response in my face, right?
No.
Now, what's the square root of 4?
Square root of 4?
Yeah, because we just talked about that a second ago. What does square root mean?
Making a square and counting one side.
Very good. So that tells me square root of 4. This is 4. We made a square out of 4. What's one side of 4? Look right there.
2.
2. All right, you. Square root of 16. What's one side?
This side is 4 and that side is 4.
Right, but square root of 16 means I just want one side, which is what?
4.
4.
Every
Easy. Any little kid can.
is 4.
That's right, because it's a square.
Easy peasy.
Easy peasy. Okay, what about this one? 25.
25 is 5.
Okay, so square root of 25
And every side
is the same thing as 5. Okay, so now let's get back to this one. Oops, and we should turn the camera around.
Yeah, that's the best idea.
Yeah, so people can see. Alright, so now I have square root of 2, and I need to figure out what the side. Is it easy? Remember we played with those, without clay and so forth? Is it easy to turn it into a square?
Yeah.
If we have clay, but if I have this block, is that easy to turn it into a square?
Yeah.
Is it? How are you going to do it?
I don't know.
That's the problem.
You just need 2 teeth.
So we're going to use symbols is what we're going to do. And I'm going to call, what do you think this side should be? If I want this times this to be 2, what should this side be?
That times that? Oh.
That looks like it should be 4, but it should be 2.
That will be 3.
3 times 3?
No, 2 times 2.
2 times 2 is 4. And that's like this one. 2 times 2 is 4. So keep thinking.
If you have a 2 and a 2, you can add it up to a 4.
Right. That's why that's a bad example. So why don't we use this one? How about this whole thing is 9? Let's use this rectangle here. I'm going to draw a picture of it. This whole thing is 9. What are the sides of 9?
That side
is what?
Is a 3.
3.
And that side is... This side is 3, this side is 3, this side is...
They're all 3. So 3 times 3 is 9, right? But could I say square root of 9 times square root of 9 is 9?
Yes.
I could, because square root of 9 is exactly the same thing as what? What's the square root of 9?
Oh, 9.
What's the square root of 9?
Oh, 3.
Okay.
Yeah.
So, I have 2 here. What should I multiply together to get 2? If I'm using my imagination.
1.
They are really thinking. I should actually put the
one.
camera on their face, because you can see they're really thinking hard. Alright. If I do 1 times 1, I get this one and I get 1.
1 times 1, no.
1 times 1 is 1, so it can't be 1. So what should it be?
2 and 2.
2 and 2. If I do 2 and 2, I get 4. But I only have 2.
2 and 0?
2 times 0 is 0. 0 times anything is 0. So what are you thinking? What should it be?
4.
4 times 4 would give me 16.
Yeah.
Don't just say anything. Think.
Yeah. Don't say
What do you think?
crazy.
Think. Yeah, don't say crazy stuff. Just think. So what do you think? If it's square root of 9 times square root of 9 equals 9, what should I put for the 2 sides of this? What do you think? What do you think? 3 times 3 would give me 9.
10 3 is not 9.
What do you think?
It's gonna be that,
All right, now,
that, or that.
it is crucial, you parents, that they figure it out for themselves. You teachers, that they figure it out for themselves. That you don't just tell them. So, let's fool around some more. What if this is 100?
Yeah.
What times what is 100?
10 times.
Very good.
10
times what?
10.
10 times 10. Very good.
10 times 10
Is 100.
It's 100.
All right.
100.
It's a 4-year-old over there, by the way. Okay, so 10 times 10, 100, right?
Mm-hmm.
Okay. So could I put square root of 100 times square root of 100? And I would get a big red square, and this would be 100 using my imagination. So you see it's square root of 100, square root of 100?
Mm-hmm.
So what should I put over here to get 2?
What
What do you think?
2 and 2?
Just 2 and 2? 2 and 2 is 4.
Mm-hmm.
So what would I have to put?
2 and...
You know what? Now I really need another camera because I want to get their face when the light bulb goes on. If it goes on today. And if it doesn't, you know what? We'll do it again another time. But I have square root of 100 times square root of 100.
100.
Right? So what do I need over here to make 2?
Oh.
What?
1 and 1.
1 times 1 is 1. Where'd it go? Here it is. 1 times 1 is 1.
Mm-hmm.
Now I want 2.
1, 2. 1 times 2.
1 times 2 would give me this. 1 times 2.
1 times
That's good thinking, though.
2.
1 times 2 is 2. But I want a square 2. I don't want a rectangular 2. So what do I need over here? What do you think? And see, this is good because hopefully high school students that watch this will be going crazy because by now they figured out what it has to be. So what does it have to be? I have square root of 100 times the square root of 100 gives me 100. I have square root of 9 times square root of 9 gives me 9. There it is. Square root of 9 times square root of 9 gives me 9. So what do I need over here?
Square root of 2 gives me 2.
Very good. From the mouth of the youngest child. There it is.
No.
Right? It has to be square root of 2.
It's so easy to get a multiply.
That's right. Times square root of 2 gives me 2.
2 2s.
Right?
2 2s.
This gives me a 2.
2.
Remember when we played with the clay? And we turned it into a square?
I totally forgot about that.
Alright. Okay. But now I have square root of 2 times square root of 2 equals 2.
Yep.
See that? Very good, Julian Marcus. You get a cookie.
What? We don't even have a cookie.
No, you're right. We don't have any cookies. So what are we going to do? I guess I'll have to give you Butterfingers. Nope, no Butterfingers. Maybe I'll have to give you a candied ginger.
Okay.
No.
Maybe I'll have to give you a dried banana.
No, I want a candy ginger.
We already ate our rainforest chocolate. So we'll have to do something else.
Daddy,
whatever, you get a prize is how it works. Alright, so look at this. Square root of 2 times square root of 2 gives me 2.
Yeah.
Took me forever to get you guys to say that. How come you couldn't figure that out? You're the older boy. Alright.
Why does it always
Now, if I say each one of these is 2, that means that one side is the square root of 2, doesn't it?
Yeah.
So how many... Oh, wait, we're just going to build it like this. How many square roots of 2 would I have right here if I'm just counting the side? 2 square roots of 2.
2
The whole square
Right.
is a 2.
Alright, let me do some erasing. Fine job, little boys. Camera on. Alright, got the camera on. Keep forgetting it. Alright, so let's go back a step. How many were in this?
8.
8, right? Because it was 4 2s. And I knew that this was a square root of 2 and that was a square root of 2.
Yep.
So the square root of 8 is how many square roots of 2? Just count them.
4.
How do you get 4?
Oh, wait, 2.
2 what?
2 2s.
2 square roots of 2.
Yeah, 2 square roots of 2.
So I'm going to write it like this. 2 square roots of 2. Alright, let's write it like that.
That's easy.
That's easy, isn't it?
Yeah, easy.
Make me a bigger square.
Make it a bigger.
With a 3. Make me a 3 square. But we're going to use our imagination. And instead of a 3 square, okay, there you go, he's building a 3 square. And I'm going to draw my 3 square.
It's 9.
Right, it's 9, but wait, see this? Instead, I'm going to use my imagination, and each one of these is 2, 2, 2. Each one of these is a 2. Right? So your first trick is to build, or to tell me how many in this. If we're using our imagination, and each one of these is 2. How many is that?
2, 4, 6,
Good.
8, 10, 12, 14, 16, 18.
Excellent.
18.
So now I'm going to say square root of 18 is how many square roots of 2?
How many square roots? 2.
Count.
18 is how many square roots?
That's my question to you. Look over here.
It is
Just count on one side.
3.
3 what?
3.
Say it.
3
3
square roots
of 2.
Yeah.
Is that hard? We're just fooling around, making squares.
Not hard at all.
Right.
Not even this much.
Not even a little bit hard, huh?
Not
Okay.
even a little.
Alright, enough of that. The hard part for the parents and teachers is being patient enough to wait for one or the other of the students to figure out what one side is. Right? So that they understand that they don't just tell you that the side is square root of 2. You have to figure it out for yourself that it's square root of 2.
Yeah.
Now wait, what if I got crazy and I said this whole thing was 3?
What?
What would one side have to be?
One side would be 3.
3 times 3 would give me 9.
3 times 3.
So what would it have to be? Just like last time. What would it have to be?
3 square roots and
close. It would have to be what times what?
Square root of 3 plus square root of 3.
Okay, except square root of 3, is it plus?
No.
What is it?
Times.
Times, very
Square
good.
root of 3.
See? And once they see the pattern. Okay, so now, square root of 3 times square root of 3. And what are we going to learn? We're going to learn skip counting.
Yeah.
And square roots.
3, 6,
all at once.
9.
Alright, so now we can count by 3s. Now we're using our imagination. And this is made up of 3s. They're square 3s, but they're still 3s. So how many in that rectangle right there? In that square right there?
And
Each one is 3.
They're all 3s.
So count with me. Count. Count out loud.
3, 6, 9.
Wait. 3.
6, 9, 12.
Done.
3, 6, 9.
Right? He wants to sing the whole song. So now I'm saying square root of 12 is the same thing as how many?
2.
2 square roots of
2.
Are they 2s?
No, 3.
Very good.
Wait. Yes.
Right? See? Learning is fun. When we get it right, it's fun, right? Alright, ooh, let's make a bigger one. Let's count this one by 3s. Ready? It's a lot of 3s. Okay. So, each one of these is 3. We're using our imagination. This is a 3 now. So wait. I'm going to point. You guys count out loud, okay?
Okay.
Ready? Alright. 3.
3, 6, 9. 12, 15, 18.
Yep.
21, 24, 27.
27. Wow, that's a 27. Good job counting, boys. So square root of 27. How many square roots of 3? Just count on the side. Give me your finger, little boy. No, yours.
Okay,
Give me your finger.
Here.
Give me your finger. This one. Give me your finger. Point.
No, I'm going to do it.
Okay. How many square roots of 3? Let's count.
3.
We're just counting square roots of 3. How many? 1.
1, 2, 3.
3 what?
3 ones.
3.
3s. 3 3s.
3 3s?
3 square roots of 3s.
Very good. 3 square roots of 3s.
I got a little bit confused there.
Yeah. It's just got to remember what to say. Right? Because here's what we're doing. We're just counting the side of this thing. And the side of this thing is the square root of 3. The whole thing, we're using our imagination now, and we're saying that that's a 3, not a 1. We can use our imagination. We can change it into anything with our imagination.
Yep.
Einstein told us imagination more important than knowledge or information. Einstein was the man. Alright, so if that's a 3, in other words, we just took this and used our imagination, and we crunched it up and we turned that into a 3. So now every time we count this, we count 3, 6, 9, 12, 15, 18, 21, 24, 27. But the side of it is just the square root of 3, right? So how hard is that? If that's 27, instead of saying that the side is 3 now, we have to use our imagination and we say the side is a square root of 3.
Yep.
Right? Alright, let's get bigger and we'll quit and we'll do something else because I know you want to do I know you want to do some which you want to factor polynomials instead of doing this. Right? Okay, so quick. We're gonna count for a long time, guys. Okay? I'm gonna help you count because I don't know if you can count this high. This is the square root of 3. Okay, the whole thing is a 3. So this is 3, 6, 9,
12, 15, 18, 21, 24, 27, 30, 33, 36.
Very good. 38. 9. We're adding 3s, right? 3, 6, 9.
32.
32. 42.
42.
40.
40.
What's 2 and 3?
2 and 3? 45.
45. What's 5 and 3?
5 and 3? 48.
Very good. That's a lot of counting, isn't it? Okay, so that's 48. So now I'm going to say square root of 48 is the same thing. Now, how many? Square root of 48 is how many square roots of 3?
How many square roots of 3? How many 3s?
How many square roots of 3? Kind of along the side.
Oh.
And you can see it.
How many square roots?
Just answer the question. How many?
It's 4.
There you go. 4 square roots of 3.
Of 3.
Right? Don't have to make it hard. Nothing scary about that. Can you see it?
Yep. It's not a big scary
small
monster.
Child. It is not a big scary monster. That's the whole point. In fact, there was a old Mortensen math video that said taking the scary monsters out of math.
Yeah.
And see, is it scary?
No.
Do you understand what we're doing?
Yeah.
Right? Now, if this is a 4-year-old about to be 5-year-old. This is a 6-year-old who's going to be 7 next year. Right?
Yeah, I'm March 2nd.
A year from now, if we play around with these concepts more, are these concepts going to be... Is this the first time we actually really played with these? We played with clay, we played with other stuff, but this is the first time we've actually really played with using the concept that we can change this into a 2 or a 3. We could change it into a square root of 5. We could do anything. But that's enough of that. Let's play around with something else.
Yeah, like
polynomials.
Daddy,
okay.
can we videotape you?
Can you videotape me? At some later date, perhaps. I'd have to shave and put a shirt on. Yeah, try not to poke your brother in the head with your elbow. All right, let's play with some polynomials. Ooh, look, you want to write it x squared plus how about 3x? Too easy, huh? Plus 2. This is like this is seriously child's play for these boys right now. All right, so there is the problem. We want to just factor x squared, 3x, and 2. Yeah. All right, let's stop and come back. Okay, so after that, Crewton Ramone's house of math.com. We are now factoring polynomials. This is the super easy one, so painfully easy they can do it in their sleep. All right, so we got x squared, 3x, and 2.
Daddy, can we do a harder one?
Of course, we can do a harder one. We're just getting used. We're just doing this for people that might be watching it for the first time. All right, so what we see here is that I have, what's this? X plus how many?
X squared plus 2. X plus 2 times x plus 1.
And the whole thing is?
X squared, 3x, and 2.
Okay.
You can see it
You're missing your 2, little boy.
3x.
Put the 2 in and we'll finish.
2.
Alright, should we make a bigger one? Oh, wait, we have to write it down.
Yeah,
I'll write it down fast. X plus
2.
And x plus, what was the other one?
X plus 1.
Okay, very good. Simple?
Yep, erase.
Now, should I go and make it a lot harder or just a little harder?
A lot harder.
Alright, we can make it a lot harder. Here we go. So
A what?
a lot. Ready? We're going to make it x squared, 7x, and 12.
7x.
7x, x squared plus 7x plus...
1, 2, 3, 4,
Now,
5.
for the 4-year-old, what is he doing? He's doing some addition because he knows that he has to get 7x, right? He's got 7x there, but he only has 3x, so he needs to figure out how many more x he needs, and he knows. So now, how many have you got? Excellent. And they're already whipping it together.
4.
Right, you can use whatever you want. There you go. So he counted out his 7.
4, 8.
Now, how many? We got to fit 12 in the corner.
12. You can do it with 3s or 2s. I mean, or 4s.
Okay, so he's got his finished. He's got his almost finished. All you got to do is put yours in. Tell you what.
Oh, yeah, you can also do it with 2.
I'll give you these. You could do it too.
4, 6.
You could make each one of these 2s, right?
12, 14, 16,
Right.
18, 20.
Go ahead and just put the 3s in, and we're done. Hurry.
Because
You're slowing down
everybody knows that,
I
hey,
love it when you say that.
everybody knows that
Yes. Put the other one in there.
4 plus 4,
You need one more.
2 plus
3,
2
6, 9.
is 4.
Mm-hmm.
So these are all 2s right here.
You could pretend that those are. That's
These
very
cut
good.
off
See?
here,
These
cut
could
off
each
here, and
be
they're
2s.
both-
2, 4, 6, 8, 10, 12. Right?
See, this is a 2.
Excellent. And you built yours with 3s? So tell me, what is the factors? You be quiet. You tell me. What are the factors?
X
Mm-hmm.
plus 3
Mm-hmm.
and x plus 4.
Very, very good. All right. Oh, I mean, this is child's play for them.
Yeah.
Right? Let's get harder.
For
Should we get harder?
2-year-olds.
No.
It's for 2-year-olds. 2-year-olds, no. But I mean, come on.
Yeah.
It's super easy. And see, we can start throwing negative factors in. You want to see them doing negative factors. You need to get a password. But it's how easy is this stuff?
Easy peasy, acapelleasy.
That's how easy it
says
is.
that.
Yes, I know. That's how easy it
And
is.
also,
All right, so let's knock out a few more problems. I'm going to turn the camera off and we'll work our way up. Because, I mean, look how easy it is. I mean, geez.
Yeah,
right?
come on.
Come on. Okay, so we just changed it very quickly. And I just x squared 7x and 10 instead of 12. And in near seconds, of course, they whipped it together. And it's, what are the factors?
X plus 2.
Mm-hmm.
X.
Oops. 2 and
X plus 5.
done. Right?
Mm-hmm.
That's the across. That's the F. Should I make it bigger? Let's get some more X. What do you think?
Yeah, sure.
Sure. Okay.
Sure.
Alright, so x squared, 8x, and 16.
Oh, 8, 16.
Okay, so how are we going to build that?
8, 16. 8, 16, right?
Oh, we put those over here.
2 8 is 16.
2 8s is 16, you're right. Is that going to fit?
Maybe. Maybe I
Let's see.
can make it.
That's good. Let's see.
Maybe I can make it.
I'm glad you knew that 2 8s is 16. Do you have enough x to fit that into a rectangle?
Maybe.
We can't copy each other.
No.
Okay, so I think you're going to have to use some kind of other 16. Let's get through that here.
But,
See, he's thinking. Look at his brain. The wheel's turning. How about you? I want 8x. I want 16 to fit in there. Have you got 8x?
Oh.
Well, see, I took the blocks away. Ah, right there. See, and then he's grabbing. What is he grabbing? Right? All right. Stop. Let your brother figure it out for himself. I want to put 16 in there. Have you got 8x? First off, my first question. 2, 4, 6. There you go. Now, what's going to fit in there?
Is this hard? I don't know what to do. I don't want to use 8s, I want to use 4s.
You want to use 4s? Well, then put 4s.
You can't change it around.
Yeah, well, make it so that a 4 will fit there. Why do you want to use 4s? Because you know 4... How many 4s are you going to need to make 16?
4, 8, 12.
Put it in there.
16. 4, 8, 12. 16.
Grab some 4s and put them in there.
4, 8, 12, 16.
I could sing the whole song.
You could.
4, 8, 12, 16, 20.
Mhm.
4, 4,
Do is how many?
Or we could sing
24, 28, 32.
You never catch a 4 out to lunch.
Mhm.
Eating peanuts or drinking punch.
Mhm.
Never catch a 4, but they do plenty.
All 4s do is tell you how many. All right.
4, 8, 12.
First off, okay, stop. Over here, this guy's about to get in trouble. Look at this. You have 6x and 8. Is that what that says?
6x. 4.
It says 8x.
16, 20.
And how much? Oh wait, you can put them over here. Would you be able to put, I got my 8x. Would I be able to put 16 in there? How many would I be able to put if I did it that way? Go ahead and let's see. Oh, see, we just did this with your brother. Do we have enough x to fit in there? You're right, 2 8s is 16. We know that. Do I have enough x? Yeah, even if I did that, I still can't do it. Huh. So let's try breaking those guys up and using 4s like you said before. But you're going to have to use all the x. There you go. Good stuff. Like it. Alright, put them in there. Yep.
Hey you.
Hey you what?
It looks kind of like a space, a Star Wars battleship, kind of.
Kind of? How do you figure?
Huh?
What part looks like a Star Wars battleship? If you use your imagination.
Yeah, it kind of looks like one.
Okay. Alright. Now, what are the sides?
What are the sides?
Count it.
X plus
Yep.
4 and X plus 4.
So, it's x plus 4?
So it's an X plus 4 square.
Very good.
Ooh.
That's what I like to hear. So there we go. Here's my
Oh, I forgot. It's a 10.
X plus 4, and then I just put the 2 right there.
That
X
looks
plus
like a
4
Y.
Alright, we'll go like that. How's that? Now does it look like an X to you? X plus 4 squared. So now, let's do this. If I have an X plus 4, and we'll end the lesson, squared, and I square root that, what do I get? What's the square root of X plus 4 squared? What does it mean? I turn X plus 4 squared into a square? So that just means I count one side, right?
Yeah.
And what do I get? If I just count one side of this?
X plus 4 and...
Anything else?
X plus 4!
Try again. X plus 4.
And X plus 4.
Do I have... I'm just counting one side. So what do I have?
X plus 4.
I'm just counting one side.
X plus 4.
You see it? That means... What does square root mean? Tell me.
We're making a square and counting one side.
How many sides?
One.
Just one side. So what do I put? So I put over here. Any side on this is X plus 4, right? If I look at this, any side of that is X plus 4. Any side of yours is X plus 4. That side is also X plus 4. Yep. But I just want to know how many sides?
One.
One. So what do I write here? What do I write there?
X plus 4.
Anything else? Okay, very good. Fine job, little boys. Okay, where do they go for more information?
Crewton Ramone's HouseOfMath.com and the boys.
And the boys, there they are the boys. So you can also go to Math Genius Making eventually.
Math Genius Making, not the boys.
Right.
Not the boys.
Okay.
I meant to say Math Genius Making.
High fives. Oh, was that a high five? The weakest. There you go. Give me a high five. That was the weakest high five ever. Give me a high five. Good one. What is that? Alright, we'll talk to you later.